Given question, a machine of mass 68 kg is mounted on springs of stiffness K is equal to 11,000 Newton per centimeter with an assumed damping factor of 0.20. A piston within the machine of mass 2 kg had a reciprocating motion with a stroke of 7.5 cm and a speed of 3000 rpm. Assuming the motion of piston to be simple harmonic, determine first the amplitude of vibration of machine, second its a phase angle with respect to exciting force, third the phase angle of transmitted force with respect to the exciting force, fourth the transmissibility and the force transmitted to the foundation.
Let us understand given data. Mass of the system capital M 68 kg, then spring stiffness K 11,000 Newton per centimeter, but standard unit is Newton per meter. So 1 centimeter, that is 10 raised to minus 2 meter. So if we take this denominator term into numerator, then it will become 11 into 10 raised to 5 Newton per meter. Then the damping factor zeta 0.20. Unbalanced mass on the reciprocating parts is given. So on this piston cylinder arrangement, unbalanced mass M0 is given 2 kg. And due to this unbalanced mass, the motion of piston is simple harmonic motion. Now due to this simple harmonic motion, the vibration occurs in the system. Then stroke length is given. So what is this stroke length? So if we observe this piston cylinder arrangement, so when this piston moves TDC, that is top dead center to the bottom dead center, then there is the stroke length L. Now this stroke length capital L is equal to 2 into crank radius. So for this system, crank radius is E. So we can say that L is equal to 2E. So from this we can calculate this crank radius E is equal to 0.0375 meter. Now the speed N is 3000 rpm. So this revolution per minute speed is given. So from this we can calculate the value of omega. So omega is equal to 2 pi n by 60, which is equal to 314.1592 radians per second. Now we can also calculate omega n. Now if we observe this system, how to calculate omega n, that is equal to under root of K by M. So K is the spring stiffness and M we have to consider the mass of this system capital M. So when we put the value, we will get 127.1867 radians per second. Now we will find out the frequency ratio R. So R is equal to omega by omega n and R is equal to 2.47. The vibrations in this system occurs due to the unbalanced mass in the reciprocating motion. Now we have to find out the amplitude of vibration capital X. So we have formula amplitude due to harmonic force divided by amplitude due to static force is equal to magnification factor. So this XST we can write here FO by K. So X is equal to FO by K into Ohm. Now this, how to write this force due to harmonic excitation, that is FO. So we know that this harmonic force is created due to the unbalanced mass M0. So we have to write FO is equal to M0 E omega square. So we will put the value. So when we put the value, we will get the answer 7402.2002 Newton. Now we will put the other value. So value of K is 11 into 10 raised to 5 and magnification factor we will write the formula 1 divided by under root of 1 minus R square bracket square plus 2 zeta R bracket square. Now value of R we have calculated 2.47, zeta is 0.2. So when we put the value, we will get the amplitude of vibration capital X is equal to 1.29 into 10 raised to minus 3 meter. Now we will move to the second question, phase angle with exciting force. If we observe this vector diagram, exciting force is Fo. Now we have to calculate phase angle with respect to exciting force. So here this Fo having angle with this vector Kx is known as angle phi, and we have to calculate this. So we have formula to calculate phi is equal to tan inverse of 2 zeta r by 1 minus r square. So value of zeta is known, r is calculated, so we get the answer minus 10.9619 degree. So here is the minus sign. So how to draw this angle? So here this is the first quadrant, second quadrant, third quadrant, and this is fourth quadrant. Now minus 10.96 degree, that means we have to take this angle in clockwise direction from this positive x-axis. So if I draw here, so this is the angle minus 10.96, but this is the minus sign, so we have to add this 180 degree. So if I add 180 degree in anti-clockwise direction, then we will get this angle in the second quadrant, and it is 169.04. So here it is 169.04 degree. So we get the answer phi is equal to plus 169.04 degree. Now we will move to the third question. Phase angle of transmitted force with respect to exciting force. Now in this diagram, transmitted force is Ft and exciting force is Fo. Now the angle between this Ft and Kx is angle alpha. So the angle between transmitted force and exciting force is known as phi minus alpha. So we have to calculate this. So how to calculate this angle alpha? So alpha is equal to tan inverse of 2 zeta r. So when we calculate, we get 44.6542. Now we will calculate this phi minus alpha. So phi is minus 10.96 degree minus 44.6542. So when we take this, we will get minus 55.61 degree. So again minus 55, we have to take this in the clockwise direction from this positive x-axis. So if I take here, this is the angle for minus 55.61 degree. Then we have to take this angle in 180 degree opposite. So if I add here 180 degree, so this is the line, that is we have to add 180 degree in anti-clockwise direction. Then this is the angle, that is 124.38. 124.38 degree. Now we will move to the fourth question. Transmissibility of machine, that is TR. So we have formula TR is equal to magnification factor into under root of 1 plus 2 zeta r bracket square. So value of zeta is given, r is calculated. So when we put the value, we will get the answer 0.2705. So it is the transmissibility TR. Now we have to find out force transmitted to the foundation. So we know that force transmitted to the foundation is Ft. Now how to calculate this Ft? So we know that this TR is equal to, it is the ratio of force transmitted to the foundation divided by force impressed on the system. So force impressed on the system is Fo. So we will take the ratio TR is equal to Ft by Fo. Now when we put the value, Fo is calculated, so Ft is equal to 2002.29 Newton.